Now we're going to take a look at question 11. The Police Department in Madison, Connecticut released the following number of calls for different days of the week during a February that had 28 days, unlike this year. On Mondays, there was 114 calls, Tuesday 152, Wednesday 160, Thursday 164, Friday 179, Saturday 196, and Sunday 130. Use a 0.01 significance level to test the claim that the different days of the week have the same frequencies of police calls. Is there anything notable about the observed frequencies? So as always, of first interest to us is the claim. And our claim is that the frequencies are equal, which if we're to put that in terms of proportions, the proportions are equal. And our opposite or negation of that is that they are not all equal, or at least one is different. So we can take that over here, write our null, write our alternate there. And we've got 7 days of the week, so we can go proportions of Monday equals, proportions of Tuesday equals, proportions of Wednesday equal the proportions of Thursday, equal the proportions of Friday, proportions of Saturday, proportions of Sunday, and our alternate, at least one proportion is different. So we'll do the R and the S. And the one that matches that they are all equal is the null hypothesis. So from here, we can go on to the next. And again, it's a right tail test because all of these are right tail tests. And our significance level is 0.01. So we're going to reject the null hypothesis if the p-value is less than or equal to 0.01. And at this point, we're ready to head on over to statdisk. And while I had some time here, I went ahead and entered the data into statdisk. Now, since we're presuming that all the proportions are the same, we're going to go analysis, goodness of fit, equal expected frequencies. And our significance level was 0.01. Our observed frequencies are in column 6. We can hit evaluate and plot, and we see that our data, our test statistic there is off in the tail. So I'm going to copy my results, but from the plot, it looks like we're going to be rejecting the null hypothesis. No. No. I don't know where that came from, why that went over there. So our chi-square is 29.814, and our p-value, which again, I'm purposely lining up here, although in this case, there should be no mistake with it. All zeros is definitely less than 0.01. So we are rejecting the null hypothesis, which means we have the evidence. So we have sufficient evidence to reject the claim that the different days of the week have the same frequencies of police calls. So let's read that all together. We have sufficient evidence to reject the claim that the different days of the week have the same frequencies of police calls. So our null was that they're all the same, and we rejected the null, so we're concluding that they are different. So not that they were just different in the sample, but we're concluding that overall for the entire population that they're also going to be different. So because we rejected it, we can actually go ahead and say something in G. If we failed to reject, we wouldn't have been able to say that there was anything of note. But because we did reject, we can go ahead and take a look. And what we see when we go back up here is that if we look at our weekend, they seem to peak, but actually, you know, a little bit more basic, you know, Monday we started 114, we went up, we went up, we went up, we peaked on Saturday, and then we were back down on Sunday again. So what was notable about what we observed here is that the number of calls per day seems to increase as we go from Monday on through to Saturday, and then they kind of cycle back down on Sunday there. Mark, let's see, anything in the chat? Mark, anything that you want to add on this one?
Nope, that sounds good.